simplest examples of geometry. It is simply base times height divided by 2, right? This formula works because a triangle is essentially half of a rectangle. Imagine you have a right triangle where the base is 4 units long and the height is also 4 units. To calculate its area, plug the values in this formula to get the answer as 4 times 4 by 2 or 8 square units. Now, this simple formula is possible to derive for simple shapes with straight lines and clear boundaries, like triangles and rectangles, etc. But what happens when the shape isn't so simple, like a curve? How do we calculate areas in those cases? We don't have a direct formula for those cases, and this is where calculus comes into the picture. Real-world problems often involve more complex shapes that don't have straight edges. For example, imagine a U-shaped valley, which is similar to the graph of y equals x squared, and you want to find the area of the land beneath that valley. For cases like these, geometry alone doesn't help. This is where calculus, specifically integration, comes into play. Integration is a fundamental concept in calculus used to find areas under curves. The key idea is to break a complicated shape like this one into tiny, manageable parts, like very thin rectangles. Then for each of those rectangles, we calculate the area and then add them up. But how do we do that? For that, just imagine slicing this parabola into very thin vertical slices, almost like we are stacking pieces of paper next to each other. Each of these slices has a tiny width, and each slice is so thin that it looks like a rectangle. Okay, for example, I can approximate this parabola as a collection of these rectangles, right? Assume each of them has a width of 0.2. This is indeed tiny. So, how many of these rectangles will be needed if our parabola extends till x equals 2? We need 2 over 0.2 or 10 such rectangles, right? And these x values will be 0.2, 0.4, 0.6, and so on till x equals 2. Now, in order to calculate the area of these rectangles, we need base and height. Base is this, so we only need height. Tell me what will be the height of these rectangles? Yes, you are right. It will be this. What is this value? It is the y value of this parabola, and that y value is equal to x squared. So the height at these values of x will be 0.2 squared. At this, it will be 0.4 squared, and so on. And here, it will be 2 squared. I have made a table of x values and their respective y values. Now the area of this rectangle will be base times height, or this. Do it for all of these rectangles and sum them up to get this. So the area of this